Okay, so this is going to be our third lecture on Ksp, and we're going to talk about what Ksp really means. So Ksp indicates the amount that is ionized. That means the smaller the Ksp that we have, the less of it ionizes, which means more of it stays as a solid. So it indicates that it is less soluble. We use this when we solve selective precipitation problems. And selective precipitation is a process that we can use to separate two different compounds or two different ions from a solution based on their solubility. And the salt or the ion that has the smaller Ksp is the one that's going to precipitate first. So we're going to look at an example now. So we have a solution that has silver ions and lead ions, and it gives me their molarities. And then it says I'm going to add NaI to it. And we want to know if the AgI or the PbI2 is going to precipitate first. Which one? Well, all I have to do is look at my Ksps for AgI and for PbI2, and I can see that the one here for silver iodide is much smaller. So that means since it's the smallest one, this one is going to precipitate first. Okay, now the next question says that if I'm going to add the NaI, I want to know the concentration of I- when each one precipitates. So we're going to go back here, we'll do AgI on this page. So we're going to have AgI, and it's going to separate into Ag plus and I minus. And we're going to say this is X, and I have 2 times 10 to the negative 4th. So my Ksp is going to be silver times iodine, and my Ksp is 8.3 times 10 to the negative 17th. This is 2 times 10 to the negative 4th plus X times X. We're going to assume that this number is really small. So I'm going to take 8.3 times 10 to the negative 17th divided by 2 times 10 to the negative 4th. And I'm going to get an X, which is my I- concentration of 4.2 times 10 to the negative 13th molar. So that's going to tell us the concentration of the I- when the AgI starts to precipitate. Now we're going to do the same thing for the PbI2. And that's going to separate into Pb plus 2 and 2 I minuses. All right, and I have 1.5 times 10 to the negative 3. This is X, and this is going to be 2X. So Ksp is the Pb times the I- squared, since I have a coefficient of 2. And I think the Ksp was 7.9 times 10 to the negative 9th. So 1.5 times 10 to the negative 3 plus X times 2X squared. And I'm going to ignore this X. So 2X squared is 4X squared. So I'm going to take the 4 times this 1.5 times 10 to the negative 3, and I get 6 times 10 to the negative 3 times x squared. So when I took the 2 and squared it, I got a 4, and I took it times the 1.5. Now I'm going to divide the 7.9 to the -9th divided by the 6 to the -3. And I get that x squared is 1.3 times 10 to the -6. And then I'm going to need to square root that. All right, and I got that number. Now, I'm supposed to find the I minus, and according to my chart, I minus is 2x. So I'm going to have to take this times 2. So this is 0.0023 molar is going to be my I minus concentration. Okay, so that's how we would do selective precipitation. And that will be the end of this week's lectures.